this video, I'll demonstrate how to transfer data wirelessly between two XBee modules. XBees are serial radio modules that allow you to use the Arduino serial port to communicate between different devices, just as if you had a real serial cable connected between them. But instead, it goes over a 2.4 GHz wireless band. The beauty of the XBee is that it's completely transparent to you. You simply need to set up the ID and baud rate of your two XBees, and then plug them into the serial line. All the wireless protocol and such is then taken care of by the XBee module itself. You just treat it like any other serial line for communications. I'll be using two Arduino Do microcontrollers for this example. Each one will have a DynamixShield with Grove connectors. I'll also use two Grove XBee sockets and two XBee 1 mW modules. The first thing we need to do is set the IDs and baud rate on our XBees. To do this, you'll also need a UART SB so you can directly connect it to your computer. Put the XBee into the slot on the UART SB. Make sure to put it in with the correct direction though. Then let's bring up the device manager and go to the serial devices section so we can see the COM port number we should be using. Then plug in the USB cable to the computer. Then we can see that COM port number 5 came up, so that's the one we should be using for now. Now let's close the device manager and open the XCTU application, version 5.2.8.6. There's a newer version of this application now, but I've not used that one. I know this one works, so I've stuck with it for now. I've provided a link in the text section to where you can download the XCTU app software. Now let's select COM5. If this is the first time you program your XBee, it will be defaulted to 9600 baud. So let's make sure it's selected from the XBee baud rate dropdown. However, if you've already programmed it with a different speed, then you'll need to make sure you select that for the baud rate, or otherwise you won't be able to communicate with it. Now let's make sure everything is working okay. Click the Test Query button. If things are good, then you should see a dialog pop up saying communication with modem is okay. So go ahead and hit the OK button. Now let's go to the Modem Configuration tab and click the Read button. This will download the current settings from the modem. We'll need to change a few of these. We're going to change the ID of this modem, along with its destination ID and baud rate. Click the Load button and go to the DynamixShield repo. Then under Sketches, XBee Serial Test, you'll see an XBee1 profile and an XBee2 profile. Go ahead and load the XBee1 profile. The colors of some of the parameters have now changed, signaling that these are new and need to be uploaded. Notice that the source address is set to 1, the destination address is set to 2, and then if you scroll down, you can see that the interface data rate is now 5, which is 38,400 baud. Now hit the right button. This programs the new settings into the XBee. Once it's done, you should see a message at the bottom that it succeeded. You can now remove the XBee. However, be careful when removing it. If you pull it the wrong way or too hard, then you can damage the pins on the XBee. I highly recommend using an IC extractor. It makes it much easier to pull the XBee out without damaging it. I'm not going to show it here, but you need to follow these exact same steps for the second XBee using the second profile. This has the opposite source and destination addresses. Now that we have our XBees programmed and inserted into the Grove XBee sockets, we need to connect each of them to an RxD2 Grove port on a DynamixShield. Then let's plug a USB cable into the programming port of the first Arduino. And let's take a look at the sketch we'll be using. Go to the DynamixShield repo, Sketches, and load XBee Serial Test. In Setup, it first opens a debug serial line. Then it opens the serial 2 line to communicate with the XBee. Then within loop, it has a small delay. It prints out that we're sending. Then it sends serial data out to the XBee. It then checks whether anything's available. If it is, then it reads it from the XBee. And if it's gotten anything, it then prints out what it's got. So let's have the first one send, "This is XBee number 1. Make sure that we're set up to go to the Arduino do programming port and that we've got the right COM port selected. Then let's download this sketch. Then let's unplug the USB cable from our first Arduino and put it as the programming port of the second one. We're going to use the exact same sketch. The only thing we're going to change is that we're going to have it say, "This is from XBee number 2. So let's change that and then download this sketch into the second Arduino. Now that both Arduinos are programmed, we need both of them to be powered. To do this, I'll plug in a 12-volt power supply into the first DynamixShield. Then let's open the serial monitor for the second shield. We're now receiving data from the first XBee module. So let's go ahead and swap the power and USB cables so that we can verify that the first one is receiving data as well. Let's reselect our COM port and then open the serial monitor. Yes, we're getting data from the second Arduino to the first one as well. You can now treat this like any other serial line to send data back and forth between these two Arduinos wirelessly. Using this Grove module with the DynamixShield makes it very easy to add wireless communications to your project. If the DynamixShield is something you might like to own, then please support my Kickstarter campaign so I can get them produced commercially and make them available. Thanks for watching.